sense that a lot of you are done. So those who aren't done, try to wrap it up in the next 30 seconds or so, maybe. We'll see how we do. All right, well, let's see how we're doing. So if you're not quite done, it's probably okay because you have the general idea. Hopefully I did my calculations correctly. You'll have to let me know if you see anything awry. I'll blame it on left my glasses in my office or something. Anyway, here's what I've got. So each one of these, I guess I did it all in my head too, so that could be the problem. My head's not right. But so this A here got 3 points for each of those six people. So 3 times 3 for that. 1 point for this one person, and so on. So I got 57, 55, and 50. Does that look right? Yes. All right. So I get excited about getting it right as well. And then, of course, A is going to be the winner because they have the most points. That wasn't too bad, was it? All right, that wasn't too bad at all. All right, so did everyone get it right? Excellent. So we've all got 100%, 100% A plus smiley face. Okay, so we can look forward to getting that into the grade book eventually. Onward. So that was my first task. My second task is to take a look at this practice test that is online right now. So let's just do a quick look over it first. You might not have had a chance to look it over, so I'll just go through it briefly, and then we'll loop back around. And I believe I put the answers up, my answers, alleged answers, I should say, because I don't always trust myself. I wrote up the answers to this at 6:30 this morning. So, I might not have had the requisite amount of caffeine yet. And, so if I make a mistake, I'll blame it on that. Okay, so first things first, you recognize that weird thing there, right? The rope thing and the knots. Okay, so that one's not bad. We'll loop back around in just a minute. Okay, this next one is a little bit weird, but it is related to, remember, binary and base 3, base 7. So this is just base 16. We can loop back around and talk about that in a bit. So that was like right at the beginning. We did stuff like that. Maybe not like that exactly, but it was close enough. We all love the Egyptian, I hope. I like it. It's kind of fun. So that's one where everyone's going to get 100% on those problems. Roman numerals, we all hate those, but we'll deal with them. So that at least we recognize. Um, the typesetting program I use, I only had the ability to make those two symbols, but you know that these are kind of stylized anyway. That the 5, for example, they would crunch all of these together and have 5 little triangles. So if you'll forgive me for not typing it up exactly the way that the book has it, Babylonian. We might need to loop around and do that one some. Okay, so this is the one, the fairness criterion, just so you know. We'll be talking about this on Monday. I mean, I could talk about it today. I have the PowerPoint right here. I'm looking at it. Right now I'm looking at it. Anyway, so I could do it right now, but I'm not going to. So we'll skip that. So don't worry about that for the exam. Although I do have the answers on the answer key. It's pretty obvious, like majority criterion is if someone has a majority of the votes, they should be the winner. Okay, anyway, going on. This dance school rankings of their favorite dance moves. I don't know why the lawnmower isn't on here, but there you go. Anyway, so this you'll have something like this where it looks like this monster problem, but it's really just you have. Oh, I noticed a typo here. These are all shifted over, so it should be here. Let's just cross these out. So I fixed it on mine. If you did it using the numbers that are here, then you'll have a different answer than me. There. That's the way the numbers should be. Sorry, they got shifted somehow in my table, so they're off by one. Yeah, so the 20 represents the first column of choices. But anyway, you'll have something like this. Hopefully the typeset, it'll be correct, so that it won't be shifted like that. But you'll have several questions. But of course, the main 4 questions you'll have to do is you'll have to figure out the plurality winner. You'll have to figure out the board account winner. You'll have to figure out plurality with elimination. And you'll have to figure out the pairwise comparison or the head-to-head, whatever you want to call it. If you're confused about what I'm saying when I say pairwise comparison, I can say Copeland. Just come ask me and I'll be happy to tell you. That reminds me, a bunch of you didn't do this one right. The quiz that I gave back to you, the plurality with elimination. Hopefully you can figure it out. Anyway, I think that's it. Isn't that it? Yeah, that's it. There's nothing else. So your actual exam will be a little bit shorter than this, but it'll be about pretty much the same size, just slightly shorter because you won't have that one problem. Other than that, the rest of the problems for sure, you should expect something like them. As far as this one goes, I don't think it's not going to be this like this. It'll be more like binary base 3, something you're more familiar with, although you might prefer this, base 16. Personally, I think I'd like to at least look that over. And what's the other one? This one. So look over this whole Babylonian business, maybe one of each of those. So I just want to make sure that we cover those and then maybe talk about voting a little bit. But this is all about you today. And so if we have time, I'll do those. If not, I'm happy to not do those if we don't have time. I should mention that if you go to our Moodle page, you will find this practice problems document as well as the alleged answers that, like I mentioned, I wrote these up this morning while I still wasn't fully caffeinated, so take them with a grain of salt. If you find a mistake, don't freak out. Send me an email or a text and just say, hey, number 3, what's up with that? And I will probably tell you you're right, and I will fix it and let everyone know. So, I guess I need to give you a little bit of help with the Roman numerals as well. So, but is there anything that you are just dying to, you're just like, I don't know how to do such and such. So I have my agenda, but I don't know, you might have your own agenda. Yeah, what do you think, Ethan? Is that right? Yeah, so the Babylonian, definitely want to hit that. Yeah, I've got it circled, so let's do it now. Just do a couple of these. As I mentioned, my typesetting program would only give me a 1 and a 10, so the other ones, not so much. But let's take this second one. So let's do letter B, and let's do letter C over here. Just those will give us a good comparison. So let's start with the one on the left, the converting each of these to our number system. Hindu Arabic is our number system. So the first thing you want to do is translate the symbols that you see here. I gave you back a quiz where some of you did this correctly, some of you did it wrong. So here's the symbols. You have a 1, then you have a 10, then a 1, and then a 10. And they will always be grouped like this. Here they're grouped. See those 3 groupings? So because there's this big space here, I think we can assume that that's one group. Here's another group. Here's another, and here's another. At any rate, I've got those 4 groupings of numbers. So that's the start, is to do that translation. Now we have to convert this from hours, minutes, seconds to just seconds. That's essentially what's happening here is you have seconds here. So those 10, I'll just put them like that. These are the number of minutes. So there's 1 minute. That's 1 minute is 60 seconds. So you remember doing this? And then this is going to be the hours. So let's add in 10 times 60 squared, because there are 60 times 60 seconds in an hour. And then what to do about this first number here? Well, I don't know what to call it. It's not a day. We're going to call it a super hour. So that's going to be 1 times 60 to the third. These are all 60s. So it's all grouped into 60s. So you have 10 60 or 10 units. There's 160. These are 10 60 squareds, and 60 cubed is the last one. Now I'll just need to pull out my calculator and do this. And if you need help figuring out your calculator, you can let me know at some point. I also have calculators over here. So if you're worried about not using a calculator on your phone because that's all you have, I do have a few calculators that you can borrow. I will bring batteries on Friday because these, it says the batteries are low on many of them. So I'll try to remember to bring some batteries. This one should work if you really want one. I know it says batteries are low, but it should work. So I'll have a few calculators up here if you need one. Anyway, 60 cubed, I happen to know what this is. That's going to be 1 times 216,000 plus 10 times 3,600 and then the 60 and the 10. So it looks to me like this is going to be 52070. Is that right? See if it's what my answer key has. Oh, yeah, there it is. Phew. 252070. Looks pretty good. All right, phew. Okay, so that's what I call the easy way. What I mean by that is whenever you're converting from Babylonian and to Hindu Arabic, this is easy. I know, if that's easy, then what's the other way? Okay, it's hard. But it's not that hard. It just takes a little bit more effort, I feel, than this. This you're just going to plug and chug. You're multiplying and adding. It's not all that bad. I know. 60. Who counts in 60s? The Babylonians do. Sorry. Anyway, getting back to this, let's do this, do the other direction. So this is Hindu Arabic to Babylonian. That is hard. It's not super hard, but I just want to make sure that you're careful about how you do it. So here's the way I would suggest you do it, is start off with your number. and divide your number by 60. Because we want to know how many groups of 60 there are. So let's do this. 1, 2, 3, 4, 5, 6 divided by 60. And I got 2057.6. 2057.6. What this tells me is that you have 2057 minutes. If this was seconds over here, that those seconds could be grouped into 2057 minutes, but there would be 0.6 minutes left over that you couldn't put into a group. So take this part right here, 0.6, multiply it by 60, and that's going to be the number of seconds that are left over. So I'll put that at the very bottom. I'm going to write this as if it were time, because time is the thing that we're used to thinking about in groupings of 60s. Okay, now that I've done that, I take this whole number part, 2057, and divide that by 60 as well. 2057 divided by 60, and I got 34.28. 283. Yeah, well, no. You're okay. Okay. I'll make sure. I don't want to leave anyone behind. That's the only thing. Okay, so I take that decimal part, the fractional part. So if you want to know what this would represent, you've got some number of minutes, 2057, and I'm going to group them into hours. So how many hours are there in 2057 minutes? Divide by 60, you get 34.28. And so I need to know how many minutes are left over. This 0.283 times 60. And that gives me 17. I know it's 16.99. Just round it up to 17. So that's going to go there. And then this 34, since that number is smaller than 60, we're just going to put it there. So you have hours, minutes, seconds. Now, if that 34 was a bigger number, like if it was 90, then you would have to do the division again. Divide by 60 again, multiply by 60, the decimal part and the integer part. You would just have like the super hour thing, but we don't have super hours here. Once you have this, now all that's left is to write this in Babylonian. Do your best. You can either do this the way that I have it on this test, which is using just those two symbols. So you could do that. 1, 2, 3, 1, 2, 3, 4. That's fine. Or you can do it the way we had it in the book. 1, 2, 3. And then the 4 ends up being sort of a compound symbol. That is to say it's made up of several different individual pieces like Lego bricks. And so this would be the 4, I guess. Like there's 4 little triangles. You remember in the book, if there were 4 little triangles up here, it'd be 4. But anyway, that's the 34. And then leave a little gap, then put 17. Probably looks better with a bunch of triangles here. I think on the when I did my best to make it look good like this. And then 36, do the same thing. 1, 2, 3. So if you want to be lazy, you can do it this way. If you want to be more artistic, make it look good. You don't have to make it look super great, but so anyway, there it is. So there's the 2 different ways of doing Babylonian. The easy way is when you have a Babylonian number, you have to translate into our numbers. The hard way is going the other direction, mainly because they counted in groups of 60. Yeah, what do you think, Alex?
Can we go over the second question
base 16.
No, I meant like on the top. Like the lines with the dots.
The lines with the dots, sure.
Yeah, thank you.
Yeah, let's get the Babylonian out of our system first. Babylonian? Any other Babylonians? Shadrach, Meshach, and Abednego? They were they were Jews that were taken into captivity. And, what?
Nebuchadnezzar.
Yeah, Nebuchadnezzar. Sure, he was Babylonian. So, what was that? Oh, true. Yeah. Well, he was still a Babylonian, just a Babylonian donkey. Very nice. Okay, so we're going to move on. Let's go back to the Kipu, and then we'll move on. I'd like to, if we have time, I'd like to hit this just to give you a couple of pro tips on how to deal with Roman numerals. We'll go back to Kipu. Oh, there's that too, hexadecimal. Okay, well, anyway, let's do the Kipu. You say it's the second one that you want to look at, not the first one? First one, number one is fine. Okay, number one then. Number one. So this Kipu is pretty straightforward. You've got these knots, and the knots are represented by these dots here, but it's really just a knot in a piece of a rope. And so all you're doing is you're counting the number of knots in each group. So there's one knot there, there's one here, 3, this is 5, this is 1, 2, 3, 4, 5, 6, 7. And then if you're at the very bottom of the rope, they use this weird way of, they would do a single knot, but it would have a bunch of twists in it. And that number of twists would represent the digit for that last number. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's 8? Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. I got 9 that time. Okay, so then on that rope there, it's going to be, what, 113,579? Couple of things, and this is all just notation from, so I'm using the notation that was presented in the book that goes along with the homework that we have. Lines like this, that just means that there are 3 twists to this knot. So this is this end knot. It's like a regular overhand knot, only you twist it more than once. And that gives you this sort of weird looking thing that they've stylized. And then the figure 8 knot, that represents a 1 at the end. And if there is no such knot at the end, then it means there's a 0 at the end. So like this one is going to be 1, 5, 3, and then there's no special knot at the bottom. So 1, 5, 3, 0. So that's 1, 5, 3, 0. So looking over here, the way I'm going to do these, I guess the 4, do the middle one here, or the second one, then leave a gap and put 3 knots, then leave a gap and then do 2 knots, and then I'll do this weird figure 8 knot, which will be represented by an infinity symbol. If instead you were doing this one over here on the right, you would do 3 knots in a group. So these are groups of knots. 1, 2, 3. And then the 4, we're going to have this twist knot that has 4 twists in it. And your book uses this sort of notation just to represent this twist. So it kind of looks sort of like that from the side. You know, imagine a coil around with one loop that goes around it. So that's pretty much it for that. I don't know who asked that, forget, oh, it's Alex. Does that answer your question about that? You're pretty clear? Yeah. Good. All right, so let's take a look at the hexadecimal maybe, and then we'll go on from there. So this is no different than binary, no different from base 3 stuff. It's just that it's base 16. So similar to the Babylonians, this is going to just be a different grouping. So here we have the A is representative of the number 10. So that's what that is. And then you have a 3, and then the F represents 15. So 10, 3, 15, kind of like the hours, minutes, seconds, if you will. And then to get the actual number, the number at the end, 15, you just write it down. This is going to be 3 times 16 because this is all in base 16. And then the 10 is 10 times 16 squared. So just like with the Babylonians, also binary and base 3 and base 7 or whatever other base, it's always going to be the same way. Once you've got that, now you just add that up and that'll give you your answer. This conversion will be similar to the conversion you did for Babylonian the hard way, except for you're dividing by 16 instead of dividing by 60. So 2020 divided by 16 is 126.25. And then I do this 0.25 times 16, I get 4. Now I do the 126 divided by 16, 7.875. 0.875 times 16 is 0.875. Oh no, it's not point. Why am I doing? It's going to be 14. And then there's 7 left over. So my 3 numbers that I need to represent are 7, 14, and 4. So the 7 is like 7 hours, but this is a different clock, if you will. So this is 7 times 16 squared, 14 times 16, and then 4 left over. But then I have to use the correct symbols. The correct symbols are listed up here. So we would do 7, and then E for 14, and then 4 will be the last thing. So on the actual test, you won't have hexadecimal. You'll have base 3 or one of the bases that is a little bit more understandable, base 5. But this at least illustrates that process of computing, changing from one base to another. All right, so we've done the Babylonian, we've done the hexadecimal. One more that I want to mention at least is this. So converting numbers from Hindu Arabic to Roman numerals and back again. This actually is useful because as you walk around, you'll see Roman numerals in lots of different places. Not so much on this campus, but you'll see on the facades of buildings, they'll have a Roman numeral usually. At the end of a movie, sometimes you'll see a Roman numeral that represents the date the movie was made. Those sorts of things. You'll see Roman numerals. At the front pages of books, oftentimes, will be numbered in Roman numerals. So Roman numerals, it's useful to at least be familiar with them. Anyway, here's what I'd suggest you do, is try to figure out the groupings. The groupings aren't going to be 100% clear, but those are the groupings. So you have, at least for this one. So this is 3,000. The XC, so anytime you have X before C or L, it means you're going to subtract. So that's going to be 100 minus 10. 100 minus 10 is 90. And then this, hopefully you recognize that, is a 5 plus 3 ones. So that's 8. I'm not going to do all of these for you, but I just wanted to sort of show you that little trick. Let me do it with this one, letter C, just so you see how this works. So we take all of the ones, all of the numbers or the symbols that are in the hundreds, so D, C, and C. Then this XC, separate that, and then the IV. So that way, if you separate into little groupings, hopefully it'll become more clear how this works. 700 is the DCC. XC is 90, and IV, because I comes before V in that, you get 4. So 794. Same thing goes when you're going the other direction, but I think that's going to be a little bit easier for you. Maybe I'm wrong about that. 642. You just have to go up here and get your symbols. DC for 600. 40 is going to be XL. 2 is, of course, just 2 lines. So hopefully the rest of them won't be too challenging. So I think that does it for what I wanted to do on this practice test. But you might have questions as well. So do you have anything, any worries, fears? Let's give you another minute. Okay, I need to give you some instructions so that you don't go nuts. First of all, tomorrow, I'll be around most of the day tomorrow. If you really want to make sure that I'm in my office just for you, you need to, request a appointment using the link that's on our webpage. So please do that, especially if you want to see me at 6:30 in the morning, because tomorrow I might not show up on campus till 7. Typically I'm here at 6:30, but it is Thursday. I'm usually a little bit more lax on Thursdays. So there's that. Second thing to note is I will be here in this room giving a test starting at 12:50. So 12:50 I have an exam. I don't suggest that you come then. However, if you come a little bit early, you can get started early for this exam. So if you really want to start at 12:50, I think that'll be okay. But if all of you come at 12:50, that might be a problem. So anyway, if you do want to come a little bit early, feel free to do so because the statistics students will start clearing out probably around 1:30. So with that in mind, once the statistics kids are gone, or most of them are gone, I will start distributing tests. And there are just about the right number of people in this class. So what I'll do is I will have one test per table. So this is a table. I'm going to clear this up. That means one test per table. And so if you really want to sit at your table, make sure you get here early and beat whoever else is sitting at your table. Otherwise, you might have to move over to here or back one or what have you. So I'll have one test per table. And then one last thing, just so that you know, when you get here, let's say you get here at 2:05. If you get here at 2:05, what you're going to see is you're going to see most of the class here already working on their exam. I only mention this because I've had students show up to the first exam in the past. They'll open the door, come in, they'll look around, and then they'll look at me with this look of horror on their faces, like they've missed something. And they'll say, "Am I late?" And I'll say, "No, these people are all early. It's okay." So if you get here and everyone else is here working, it's fine. You're not late. So don't fret. But just be aware that that's the case, that's what's probably going to happen. Okay, here's what I'm going to do is I'm going to stop the recording so that you can come and whisper your little secrets into my ear. Otherwise,